Okay, so I'm sunburned, so my face is peeling right here, just FYI. Look the other way. So a way to memorize all this fun stuff, really and truthfully, is by using your crossing. It doesn't matter how you do it. I always think about a bra with double D's here, and you want to deck a DA, right? That way you don't get it mixed up with Essie. And if you can figure that out, that's your really hard part. The antecedent immediately, that's what you've already done before, right? You've already went up to kilo before. So really and truthfully, your biggest issue is going to be this top and this bottom. All right, so I don't know how you memorize it, whatever you want to do. I always think on, and then FA for family. That's just me. I don't know why that works for me. And then up here I always think, thank God for mom. Anyways, once you figure all that out, the number system is very easy. Negatives and positives, I don't really worry about. I guess for me, you'll know them, but it's easier to not worry about them until the time is needed. For example, deca, base. Alright. Alright. So once you figure out what they all are in the order, now it's just figuring out those numbers. Well, I'm not going to worry about any negative numbers or any positive numbers. I'm just going to number them the way I see. For example, 0 is always going to be the base, right? So we're going to figure out how to do this. And there is something to what I want to teach you because it works. 1, 2, 3. Once you get to 3, you go by 3s. How cool is that? 1, 2, 3. Go by 3s down. Very simple, right? Okay. So if that works, now we got to figure out how to solve these problems. GMA problems with the grams, moles, atoms are using dimensional analysis the entire time we do them. That's all we're going to be doing. What is dimensional analysis? Well, if I have 3 foot in a yard, could you tell me how many yards are in a mile? By going through, breaking it apart, right? If every person here has 2 feet or 2 legs, and I have 10 people in here, how many legs are in there? 20, right? That's dimensional analysis. That's all it is. But when we start throwing in grams and moles and atoms, you're like, what do I do? And then I start saying, why are you not doing what I told you to do? So we're going to start today teaching you how I expect you to do. You may be the smartest person in the world, and you're like, I can do this on my own. I don't need to worry about anything you're teaching me, Miss Smith. I know how to do this. And I'm going to say, okay, do it that way. Go for it. And then in about 6 weeks, we change it up. We add about 3 or 4 steps to that, your way of doing it, and you have no idea what you're doing. You're going to come back and say, can you help me? I'm going to say, see me after school. Okay? So learn it now so you don't have to do that. We're going to start simple. If I have 3 meters of something, or 3 meters, and I want to go to kilometers, what do? Well, I have a handy-dandy cheat sheet over here that works wonders as we go through it. I'll put it on. Okay. So the first thing we're going to do is start with what you know. Well, what do you know? What am I giving you? What's am I giving? It's normally the thing with the number in front of it. Okay. So 3 meters. It says what is on top goes down bottom. What is on top? Meters. So what's on bottom? Meters. Now you can set it up this way, or you can set it up this right here way with boxes. When we get farther on, you'll see me doing this because that way I see everything evenly out. But it's up to you, whatever you want to do. Right now, I don't care. 3 meters. We'll put meters on bottom. Always go through the base. Now, when I say always go through the base, that means if I'm at a base and I'm going somewhere, that's easy peasy, right? But what happens when I'm starting and I've got gigameters? Well, I can go from gigameters down here to micrometers easy, but I got to do a bunch of crazy stuff, and I got to think about what's negative and what's positive and whatever else is going on. Do you guys want to have to worry about the positives and negatives, or do you just want to be able to solve it the same way every time you deal with it? For me, I like to solve it the same way every time, and I don't have to worry about any negative and positives, because I know for a fact I'll get confused. So what I do is I always go to the base first, and then go down to where I need to from there. That makes it simple, The same pattern of rules works every time, and you don't ever have to worry about anything different. So with that being said, we're going to go from the base already and move to kilometers, right? Or kilometers. So where are we going? Well, I don't have to go to the base any longer because I'm already at the base, right? So we're going to put KU on top. Here's the tricky part. We're going to pretend that this is a ladder. Do y'all see it? Okay. So the next one says the one goes with the tallest prefix on the ladder. What's the tallest? Kilo or base? Kilo. So the kilo is going to get the 1. Simple. 1 times 10 to the whatever square power goes with the other unit. So what's the other unit? Meters. So you can choose to do it one of 2 ways. And I'll show you. The square is going to be filled in with the non-zero number. Now, what is the non-zero number? 3. So this means it's raised to the 3rd power. Okay? Really and truthfully, what it also means is it says 1 with 3 zeros behind it. Make sense? That's all it means. So you can choose to put it in this way in the calculator, or you can choose to put it this way. It doesn't matter to me. You won't have to worry about your negative and positive signs by doing this at all. Because now you've already got this now this 3 on the bottom, right? You should have been through a class like maybe geometry. And geometry taught you a lot about exponents at the very beginning. Do you remember that? When you bring an exponent from the bottom to the top, what do? Change the sign. So technically speaking, when we solve for it, we should get some negatively, a negative sign on the 3, which will in turn make it a whole number, big whole number, or a small decimal number. Let's think logically. What's bigger, a kilometer or a meter?
Kilometer.
Kilometer's bigger. I only have 3 meters. Logically speaking, are we going to have like 1 kilometer, 25 kilometers, or something smaller than all that? Small, because we didn't even make the threshold of 1,000 of them, right? That makes sense? So you've got to use your mind. You might plug this whole thing and do it wrong, and then you've got to figure out, oh, that doesn't even make sense. That's that going back to that scientific method yesterday with data and your trends and your patterns. If you look at something and your weights, one weight over here is 45 grams, and you go back and reweigh it, and it's now 39 grams, and you didn't do anything to it, there might be some error that you need to check on. Just make sure it makes sense. So with that being said, let's put this into a calculator and plug it out. Pull out your scientific calculators for me and put them on your desk. If you do not have one, I do have some, I'll give out 6 of them. But it's mandatory that every person in here actually puts and uses their calculator to put this in today. Because I'll teach this one time. I'll teach it one time, and then after that, you should know how to do it on here. Everybody else got a calculator? You need one, Tyler?
Yes, ma'am.
All right, can you pull over here and share with somebody? But then what you're going to end up doing is you'll end up doing it on your own as well, okay? All right, has everybody got somebody or something? All right, does everybody have black calculators? What do you have? You have black calculator? Gray? 368, gray? Who said no? Okay. All right. So, I'm going to put it up on the board so that the people that are in board block can see it. What you're going to do is you're going to put the number 3 in. So it's right here. Times. And then you're going to put 1. Now, obviously, you should already know that that's 3 times 1 is 1, right? Or 3 times 1 is 3, right? I know you know that, but there's some people that forget to put the next number in there just because of the fact that they're not paying attention. So we'll start looking at 1.01 for hydrogen, or 12.01 for carbon, or even 22.99 for the sodium's gram weight. We start looking at that, don't forget, oh, what do I do with this number? Well, we're going to multiply everything on the numerator, and then we're going to divide it by everything on the denominator. Okay, just like a fraction. So 3 times 1 equals, go ahead and match equals, and then we're going to divide it by what? Say that again? No? What's on
1
bottom?
times 10 to the third.
It's actually, don't write anything yet, it's 1 times 10 to the third power, right? And we can do that by literally mashing 1, E, and then what? 3, and then equals. Now I'm telling you to put the 1 in because somebody's going to forget that when we start doing 6.02, 2 times 10 to the third power. But go ahead and put that 1 in and get used to it right now. Once you put that in, you should mash equals or enter and get an answer. Anybody get an answer? What's your answer?
0.03.
0.003? Is that the right answer? Everybody agree? It's not the right answer. Anybody know why it's not the right answer?
You don't have to.
My unit. In chemistry, you will realize that I will not accept any answers unless they have a unit at the end. The reason we need that is because I need to know if you're looking at grams or kilograms or inches or meters or whatever. And if I don't tell you that I need 3 drops of sulfuric acid and you use 3 gallons of sulfuric acid, what just happened? You just screwed up all of them, right? You might have blown up school for all I know. What is 3 divided by 1,000? Same thing, right? All right, easy peasy. Everybody understand how to do on the calculator now? All right, so let's try one where we have to go from the bottom to the base, or from something that's not a base to the base. Let's go from.
That should not matter. Whoever it is.
And I know this sounds really simple. I understand it's a simple lesson, but I need to make sure you understand it, okay? Because when we're adding to it, it does kick us in the butt later. We're going to go from nanometers to meters. So we're going to start what we know. What do I know? There we go. Nanometers, right? Set it up. What goes on bottom?
Nanometers.
Nanometers, very good. And then what's going to go on top? What's my base? For this example, it's going to be meters, right? Well, lucky you, that's where we're going, right? So let's go to meters. Now, what's taller on the ladder? Meters is the 1. So down bottom is going to be 1 times 10 to the, let's figure it out. Base of nanometers. It's going to be the 9, so we're to the 9th power. Plug and chug and see what you get as answer. Anybody get an answer? What is it?
0.60.
Say really loud.
0.60. 45.
That makes sense? Okay, so if I were to correct it, 1, 2, 3, 4, 5, 6, 7, so 4.5 times 10 to the -7 meters, right? Oh my gosh, she just blew that out of the water. I didn't know anything about that. Gosh, she did that right. If it's, think about it, let's just logically say, I don't know if it's going to be a positive or a -7. Let's think about it. If I multiply this by 7, am I going to get a little number like that? All right, that's it.